Okay, here we are going to see the relation between the value of k and the concept of the proportion. So if you look at this part, y1, y2, y3, y4, and then x represented by x1, x2, x3, x4. So when you get the variation, which is y over x, or y varies directly as x, y2 varies directly as x2, y3 varies directly as x3, and so on. Actually, you will get a constant, right? Because from what you did from the taxi fare just now, everything is 1 ringgit 20 cent. So when it comes to variation, actually they're all represented by constant. Okay, so also the same thing if you look at the right part here. Look at this. The relation between the value of k and the gradient of a straight line passes through the origin. Gradient is m. We have learned this before, right? So you can see it is y over x1. So the value is also a constant. So it is k. This relation is true only if the straight line passes through the origin. If the straight line doesn't passes through the origin like this, then this is not the constant. Okay? Okay. And also it means that this is not the graph which is y varies directly to s. You must remember it is from the origin. Okay, now we look at this. When y varies directly as x, then the relation is written as y varies directly as x. You remember the symbol, huh? It is something like this. Okay, we got to practice it. I also cannot draw very nice. From this relation, the value of constant of proportionality, k, can be determined. That is y equal to, k equal to yx. So you remember this, when you are given y is varies directly as x, then because they are constant, right, you are write down it is in the form of y over x. They are constant, right? K is equal to y over x, right? Therefore, you can just remember this part here. Okay, we go to the left. Whenever they give a variable, for example, a varies directly as b. Okay, so you just follow directly a is equal to k times b, because this represents a over b. It is a constant. Can you remember? Okay, so if you look at this part here, for a direct variation, y varies directly as x can be written as y varies directly as x like this. So y equal to kx. Okay? Can you understand or not, class?
Yes, madam.
Yes.
Yes, madam.
Very good. And we proceed. Okay, I'm going to go through the next one with you. Okay, this part here, the mind mobilization tree, is the same as what we did just now. The only different thing is they change it to x squared and also x cubed. So from the finding, actually, this part here, y over x to x squared, you will get the same number, which is 3.142. Whereas y over x cubed, there you will have a different number. So when you compare the one that is a fixed, this one, the fixed number, it represents the constant. Okay? The reason you need to know the constant is because they will ask you whether they varies directly or not. So you need to determine if they varies directly, meaning that they have a constant. Okay? So let us look at this one down here, this part. So from there, hold on. Okay, look at this part. From the result, you get A. The value of y over x squared is a constant. Hence, k is equal to y over x squared. For B, the graph of y against x squared is a straight line that passes through the origin. It must be like this, if they varies directly. C, variable y varies directly as variable x, this part here. Okay, if this is x and it is a y here, then you will say that variable x varies directly as variable y. Okay, that is how you read it. Okay, then in general, so you look at this part now. For direct variation, y varies directly as x to the power of n can be written as y varies directly as x to the power of n like this. And then this is the form of variation relation. When it comes to equation, remember you have to add the constant. So it becomes y equal to kx to the power of n. Can or not?
Can.
And
Okay, let's continue with example 2. This one I'm going to show it to you over here. Example 2. I think this is the one. Okay, example 2 here. Okay, this one. A toy car moved from a state of rest. The distance traveled by the toy car, y, this one, changes with the time t, this one, as shown in the table below. Okay, now you look at this. Determine whether y varies directly as t or t squared. So if you want to determine whether they varies directly or not, you must find out that they have a constant k. If they don't have a constant, meaning that they are not vary directly. Okay, so over here, you look at the solution, everything is the same. T is 2, 4, 6, 8, 10, 12, and then this part here, they just copy down everything, which is the same. So we are going to find out y over t. Y is 14, so it's 14. T is 2, so 14 divided by 2, we get 7. Same with this one. 28 divided by 4, we get 7. Same with this. 42 divided by 6, we get 7. And so on. 7, 7, 7. It's a constant, right? Then you find out another one because they want you to determine whether y varies directly as t or t squared. So this one is y varies directly as t. This one we find out y varies directly as t squared or not. So for t squared, you need to square the t. This becomes 2 squared. This becomes 4 squared. This becomes 6 squared, and so on. So this will be 14 over 2 squared. We will get 3.5. This is 28 over 4 squared. So you get 1.75. And then you can see the number over here. Are they the same? Are they the same?
No.
Not the
no.
same. Yeah, very good. They are not constant, right? So you can answer already because they ask you to write the relation in the form of variation. The one that we have variation is this one. The one that we don't have variation is this one. Okay, so how are you going to answer? Actually, you are just going to answer this one. Y varies directly as t. This is the answer. Okay, and then for this one, y does not vary directly as t squared because y over t squared is not a constant. Okay, that is how you find out whether they varies directly or not directly. Okay, so we continue for example 3. Okay, this one is very simple. You just need to see from the graph. Okay, we look at A. By drawing the graph of y against x, determine whether y varies directly as x. So from the table given, you are going to plot x is 0.4, y is 1.5. So 0.4, 1.5 here. And then 0.8, 2 here. 1.2, 2.5 here. Does it go through the origin? No, right? If it doesn't go through the origin, you just remember, if no go through the origin, it does not vary directly as x. Okay? And then if we look at B now, same thing, from the table given, you are going to draw the graph to add. So actually it's not to add, sorry. They ask you whether y varies directly as x squared. So we need to find out the value of x squared over here. 2 squared is 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. So when you plot, you are going to plot 4 and 8. 4 and 8 is right here. 9, 18, here. 16, 32, here. 25, 50, here. Okay? And then it's a straight line, right? And then you find out that it goes through the origin. This is the most important part. When they passes through the origin, so this y varies directly as x squared. That is how you answer it. Okay? Now we continue with the next example, which is example 4. Okay, let's see. Where is example 4? Okay, this one. Now we are going to start to solve the problem. So this is example 4 from your book. It is given n equal to 0.8 when n equal to 0.125. Express m in terms of n if m varies directly as n. So m varies directly as n is like this. Okay, to continue with it, we are going to write down in the form of the equation m equal to kn. Remember, when you change the equation, you must have the constant. Okay, now your m is 0.8. We are going to substitute the m 0.8 equal to k times your n 0.125. So from here, we are going to get the value of k. K is 0.8 divided by 0.125. Okay, to get the answer, you can see from the calculator on the right here, 0.8 divided by 0.125. We will have a 32 over 5 or 6.4. Wait, yeah, I do it correctly. Let me see. 0.8 over 0.125. Yes, correct. Okay, so it's 6.4. Okay, but then they want you to express m in terms of n. So we haven't write down m, right? M, go back to this, is equal to the k. You found out already, 6.4. Then copy down n. Okay, so that's your answer for part A. You ask me if any question here. Anyone have any question? You can just voice out. Any questions so far?
No.
No.
Okay, good. Then we continue
No.
part B. Thank you for answering. Now we are going to look at m varies directly as the cube root of n. So how to write that? You need to start with m varies directly as the cube root of n. Second step, we are going to write down in the form of equation. M equal to k times cube root of n. So substitute all the value. M is 0.8 again, equal to k times cube root of 0.125. So get the answer. K equal to 0.8 over 0.125 cube root. Again, we press the calculator, okay, which is 0.8 divided by cube root. Cube root of 0.125 is actually 0.5, right? So you will get an 8 over 5 or 1.6. Okay, so K is equal to 1.6. Therefore, again, go back to this to answer the last part. M equal to K is 1.6. So write down and copy down cube root of n. That's for the answer for part B. Okay? Now we continue with example 5. Example 5. Okay. I need to take off my mask. Okay, look at example 5 here. Am I clearer without the mask?
Yes.
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 Very good. Let's see. Example 5 here. Find out the extension. They give you the extension of a spring X centimeter varies directly as the mass of the rod, W gram. So this is the spring, this is the rod hanging on the spring. It is given that the extension of a spring is 3 centimeter when a rod of 200 gram is hung on the string. Express X in terms of W. So you have to express X in terms of W, meaning that X varies directly as W. Change it to the form of equation, it will be X equal to KW. So you're given the lot of the extension of a spring is 3 centimeters. So it will be 3 equal to K times 200. Okay. Then to find out the value of K, it will be 3 over 200. So you can press your calculator again here. 3 divided by 200. It is equal to 0.015. Okay, so K equal to 0.015. Okay, then last part, express X in terms of W. So go back to this, X equal to 0.015 to represent the K that we get just now, and copy down W. That's last answer. Okay, so we move on to example 6. I'm not going to finish all the example. There will be 2 more examples because example 8 will be the same, so I'll skip that. You can read that on your own. So we have 2 more examples. We look at example 6 now. Okay, this is example 6. It is given y varies directly as x. So straight away you can write down already y varies directly as x. If y equal to 0.14 when x equal to 0.2, calculate the value of y when x equal to 5. So now you are given a number for x. You have to find out y. Never mind, we do it slowly. Change it to the form of equation first. Y equal to k x. Hopefully you know. So you're going to substitute y equal to 0.4 in front, equal to k, and then the x is 0.2. So just put it in bracket. Okay, then you find out what is the value of k. If you are fast enough, you can get the answer already. 0.4 divided by 0.2. 0.14, sorry, divided by 0.2, you get 0.7. Okay, so k is 0.7. But we haven't done yet because you have to find the value of y, this one. So substitute the value of k into this equation. Y will be 0.7x, right? So when x equal to 5, this x here equal to 5. What is the value of y? It will be 0.7 times 5. 0.7 times 5 equal to what?
3.5.
5.
Very good. I don't have to show using the calculator anymore. You understand enough. 3.5. Done. Okay. Now we continue with part B. Find out the value of x when y equal to 0.875. So you already have the equation. Y equal to kx, whereby your k is 0.7x. So you're going to substitute the y here. 0.875 equals to 0.7x. To find out x is 0.875 divided by 0.7. Again, 0.875 divided by 0.7, right? Is equal to 5/4, or is it equal to, sorry, 0.875 divided by 0.7. Okay, so it's equal to 1.25, correct or not?
Yes.
Correct.
Yes.
Okay,
Yes.
last example now. Last example is example 7. Okay, this one here. Make it bigger for you. The area L centimeter squared, a semicircle, of a semicircle varies directly as the square of its diameter. Okay, I'm going to make it fancy now so that you stay alert. This is the area in L, varies directly as the square of the diameter D. So we can write down the relation already, which is L varies directly as D because they said the square, so D squared. Okay, this is the diagram given. You can go through it yourself. It is given that the area of the semicircle is 3.08 centimeter squared when the diameter is 2.8 centimeter. So you can replace this. This is the area. L equal to kd squared. You write down first. Then L is 3.08. Replace it because that's the area of the semicircle. Okay, copy down. D squared, this is the diameter, so it will be 2.8 squared. Therefore, K is equal to 3.08 over 2.8 in bracket squared. Then again, you press your calculator. Oh, I lost my calculator here. You can refer to your book. So for 3.08 divided by 2.8 squared, we will get 11 over 28, sorry. Okay, after that, you are going to generate back your equation here to replace the value of the constant. So L will be 11 over 28 D squared. Okay. Lastly, they ask you to calculate the value of D when L is 19.25. So you're going to find out the value of D by replacing L is 19.25 here. Okay, we are going to do it on the right. 19.25 is equal to 11 over 28 D squared. In order for you to look for D squared is equal to 19.25 times 28 over 11. So after you have get the answer, you are going to square root it because this one, they have a square over here. So the answer is actually equal to 49.
Yes.
In order for you to get D, it will be the square root of 49. So the answer is 7. 7 what? Because this is the diameter, right? The unit is cm. So write down centimeter. Okay. There's another alternative method that you can see from your book, which is using the ratio method. That is, I think I rub off this part here.
Madam,
Yes.
why the D just now was squared?
Why it was squared, is it?
Ah,
It is-
yes.
It is here. Let me show it to you. I rub off clearly first. Here, the area of the semicircle varies directly as the square of its diameter. Understand?
Oh, okay, okay.
That's why you have to square it. Okay, so now we are going to use, yeah, you're welcome. So now we are going to use the alternative method, which is the proportional method. How to spell proportional? Proportional. Long time didn't write. Okay. It's up to you which method you want to use. You choose it yourself. So for proportional method, it will be L1 over D1 squared. L1 to represent the L that we have just now, this one. And then the D squared is this one. Just indicate using the 1 here. It will be equal to L2 over D2 in bracket squared. Okay, if you don't want to write this, doesn't matter as long as you understand. By replacing the L given is 3.08. So substitute 3.08 over this one, 2.8. Is equal to, they want you to find out the value of D when L is 19.25. So you replace the L here, 19.25 over D. Therefore, you can find the D already. It is 3.08 over it is 3.08, and we have to do it the other way around because it is cross multiplying. It is like this actually, I'll show it slowly to you. So actually here is 3.08 D equal to 19.25 times 2.8. Okay. To get
Madam, you forgot the square.
Thank you very much. Thank you very much. Azra, is it? Okay, it is 19.25. You sound familiar. Times 2.8 over 3.08. Then you get the answer. Yeah.
The 2.8 is square.
Which one?
2.8. You forgot to square it.
Oh, correct. Thank you. Because of this one here, I forgot about it. You are paying attention. That's great. Okay, so then you press your calculator. I don't want to find my calculator anymore. So you press and then you will get the same value over here, whereby the D squared is actually 49. So D will become square root of 49 and you get the same answer exactly as 7 centimeter on the right. Are you okay, class?
Yes.
Yeah, okay.
Yes.
Yes.
So this is the last part of our lesson. Because just now I told you example 8 is the same. You can go back and read about this. Example 8, you can see this part actually the same. And then the alternative method using the proportional method. Everything is the same. So your exercise. Okay, you need to tick your exercise. I've choose some questions for you. But I don't want you to do it all because it's quite a lot. So what other question that you need to do are question number 1. Okay, is your book with you?
Yes.
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 Question number 3. Okay, after that, I want you to do question number 6. And lastly, question number 8. Okay, so you have 1, 2, 3, 4 questions only. After you have done it, turn it into me by using the attachment. You know how already, right?
Yes.
Yes.
Let's see your face now. Everybody turn on your video camera. Okay, that's great. I have 46 students today out of 51. Not sure who are not here. Can you identify your friend who are not here?
Irfan.
Oh, Irfan, what happened to him?
No, madam.
Don't know. Who else? Who else is not here? Can you identify? But the number of students who present are getting better. Oh, Sophia, how nice to see you here. One Irfan and also Yasmin. Okay, that's all for today. Do you have any question? No.
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 Nope.
So we stop here. Our class only took about 36 minutes, which is good. Less time. I think you prefer shorter time, right? Okay, I'll see you
Yes.
again in the next lesson. Bye.
Bye,
Bye.
Thank you,
madam.
madam.
Bye, madam. Thank you,
Bye,
madam.
madam.
Bye,
Thank you, madam.
Madam, thank you.
Thank you, madam. Bye, madam.
Bye.
Madam, have a nice day.
Madam, don't leave first.
Huh?
Don't leave first.
Oh, okay.
Bye, madam.
Bye.
Bye, madam. Have a nice
Bye.
day.
Yeah, you too.
Madam, smile, madam.
You want to capture my face? Don't